In this video, we introduce our ICARA 2025 paper, SurgPose, a dataset for articulated robotic surgical tool pose estimation and tracking. In this work, we create a new dataset for the articulated surgical instrument pose estimation task. So far, SurgPose consists of 30 for trajectory videos. We only provide 2D key points of 6 kinds of instruments for each frame, but also include stereo image pairs and raw PI proprioception data. Compared with existing datasets, SurgPose is a larger, more comprehensive, and higher quality benchmark. The motivation of this work is simple. Surgical pose estimation and tracking are important. It is the foundation of many downstream applications in robotic surgery. For example, in surgical data science, the motion of instruments is the determinative data for surgical phase estimation, skill assessment, and action segmentation, etc. Surgical augmented reality, accurate pose estimation enables hand-eye calibration, which is the key component to register multiple coordinate frames in our system. Teaching robots to do surgery is another sexy task. Some recent works learning the policy of autonomous manipulation by 2D gripper trajectories. Without pose estimation and tracking, this method will be impossible. However, there are few public datasets for the surgical instrument pose estimation task. Common used datasets, Endovis 15 and Jigsaws, have significant limitations. The data size is limited, the image resolution is not high, key point labels are sparse, and only with a single class of surgical tool, and so on. Thus, building a better dataset for this task is significant. To build a dataset with key point ground truth, manually labeling key points is time-consuming, cumbersome, and labor-intensive. Thus, we proposed a semi-autonomous method to simplify human intervention. We use UV reactive paint to mark the key point on the instrument. This UV paint is invisible in natural light, but glows under UV light. We define workspace and trajectory for each patient side manipulator. After that, we execute the trajectory twice under different lighting using DVRK. In UV light videos, the markers have bright fluorescence, so it's easy to use SAM2 or other segmentation method to extract the key point's position. This page is a visualization of a sample data. Since we have calibrated stereo camera parameters, we can use the stereo matching algorithm to calculate the depth map. You may think these links are helpful to know more about SurgPose. If you have any questions, feel free to reach out. Thank you for listening.